Okay, day 5 notes is the last set of notes that will be covered on your test. There are only 2 examples. The first example we've mostly done before. The second one we've pretty much done before. So there's very little here that's new. In example 1, we're finding all of the zeros. We've already done that. How many zeros are there going to be in number 1?
4.
4, x to the 4th. What I want you to do right now is do example 1. So you have your calculators out, graph it. In your group, find all 4 zeros, please. You have 5 minutes, and then we're going to come back and go over. Okay, if we can look up here. Here are the 4 answers you should have gotten. The only 2 we can see on the graph are x equals 2 and x equals 4. It doesn't matter the order that you do synthetic division with. As a reminder, though, after, bless you, you do synthetic division once, those are the numbers you bring down. Don't restart. So everybody, regardless of the order you went in, should have gotten down to the quadratic 2x squared minus 2x plus 5. And then you're going to have to do quadratic formula. Like we said, it makes sense for us to get 2 imaginary answers because we can't see them on the graph. With this quadratic, instead of doing quadratic formula, could we have completed the square? Well, we could, but what would we have to do?
Just take a
divide out that first 2. Okay, so the only thing that was new about this problem really is that we got I in the answer. Also though, did you all read the directions and see that we didn't actually fully answer the question? Did anybody notice that? Question says, write the polynomial as a product of its leading coefficient and its linear factors. That is very important. Here's what that means. We are rewriting this polynomial in factored form. So it's going to start with p of x equals, because the lead coefficient is 2, a 2 goes out in front, and then all we're doing is taking each of these zeros and putting them into a factor. So if x equals 2 is a 0, that corresponds to x minus 2. If I set that equal to 0, it would give me x equals 2. So then we also have x subtract 4. The complex ones are the hardest ones in my opinion. We have to subtract, but we got to make sure that we have good notation. So that would give us x subtract 1 plus 3i over 2. And you're going to need these parentheses. Why do I need the double parentheses? Why do we need parentheses after subtraction? Distribute. Yeah, distribute. And then the other one is x subtract 1 minus 3i over 2. So that is the factored form of our original polynomial. Sometimes we like to simplify these complex ones by distributing the negative. So you also might see it written like this. X subtract 2, x subtract 4, and then this would be x subtract 1/2, subtract 3i over 2, and x subtract 1/2 plus 3i over 2. Those are equivalent. All I did was distribute the negative. Alright, so this makes the 1 negative, this makes the 3 negative, this makes the 1 negative, this makes the 3 positive.
Do you always use negative for those? Like if you positives around?
This negative, what negative are you talking about? Yes, that one's always going to be subtraction.
Where does the 2 come from the first?
This
That's what you
2 comes from the original polynomial that had a 2 out in front.
you always put that.
Yes, whatever that number is always going to have to go in your factor.
Just say your final answer.
Even if it's 1?
Yes. I'm fine if you leave your answer as the first line, but on the answer key it might be expressed as the second line. You will have that on your homework. Any questions before we look at the last example together? No? Okay, last example we've done before. Very quickly, let's get this last one done and then you all will take a break. Find a polynomial function of lowest degree with integer coefficients that has the given zeros. Okay, we've already done this before. Here's how we started. There's a 0 at x equals -1, and another 1 at x equals 1. And the last one is at x equals -5. If you remember then, we moved everything to the same side. So if I add 1, that would give me x plus 1 equals 0. If I move the 1 over, it gives me x minus 1 equals 0. If we move the 5 over, it gives me x plus 5 equals 0. All that does is tell us what our 3 factors are. So factor number 1 is x plus 1. Factor number 2 is x minus 1. Factor number 3 is x plus 5. That's just another way of doing what we did in the previous problem. In the previous problem, I told you always subtract. That's all I did here. If I subtract negative 1, it's a positive 1. If I subtract 1, subtract negative 5, becomes a positive 5. So this is exactly the same work as we did in green, just looks differently. Okay, that is not your final answer. I will not accept that because that is not a function. That's not a function, that's not an equation, that's an expression. It's missing an equal sign. So you have to set that equal to something. We've been using p of x. I don't really care what you use. P of x, y, f of x, anything to show that it's an equation. Yeah. Okay, one thing I want to point out before we take our break. I don't know if you saw this in the directions or took note. It says find a polynomial function. It doesn't say find the polynomial function. It says find a, which means there's more than one answer. So this is not the only answer. Does anybody know why? Where another answer would come from? No, the calculator is not just going to give us another answer. Be the same answer, but good idea. Yeah, I don't care that you all multiply that out. Do you remember when you saw a picture of a graph and you had to write the equation?
Yeah.
What did I say was really important that you included in that equation? An A. Remember how there's a lead coefficient out here? That number can be anything at once. We can put 1, 2, negative 5, negative 10,000, 1,000,000.7. That's why there are actually infinitely many answers, is because of that number out in front. I don't care that you put A there. If you want to, great. But just know that you can have a number out in front.